I assume that everybody can now see the screen here, and you'll see that I have defined a matrix A up here. And remember this arrow. We have an arrow that looks like this, which basically means that if I have a number, say 12, I'm now assigning it to B. I can also do this. I can go B equals 12, and that does the same thing. Or I can go 12 and do this, and it'll assign it to B as well. All right, so you see I have these three options to enter the number into B. Now, this one here is more traditional, but just to let you know what this one does, so whenever you're running a line of code within R, you have to hit Control Enter. All right. And now if I want to see that B, I got to type B and go Control Enter. And then you'll see down here that the B is equal to 12. So what happens is 12 is assigned to B, and the same thing here, 12 is assigned to B, and the equal sign B equals 12. So you don't want to go, I don't think it'll work to go 12 equals B. Whoops. Yeah, down here. Notice it's down here. So if I hit return, you'll notice that there's an error left-hand side to assignment. So that tells you that you can use this method or this method together, but you can't use an equal sign if you're doing it this way. Now, a lot of pure programmers prefer to use the less than sign and the hyphen to illustrate assignment of 12 to B or 12 to B up here in this direction. But that's a kind of a nuance that some people like and others don't like. The other thing I'm going to point out is that I used a little b here, a lowercase b. Here I'm going to use an uppercase B. And it turns out that R is very sensitive to the whether you're using a capital or a lowercase letter. All right, so first off, we're going to assign this matrix. We're going to create a matrix. So we're going to assign the matrix to A using this less than and then a hyphen, and we're going to call it matrix. Now, within that matrix, we're going to do this, and we use a C always to denote some kind of thing like this. So if you hit enter there, you'll see that it's 1, 2. So C is like an assignment, or it creates numbers and other things, as we'll see shortly. So don't forget to put that C, and then you have in brackets, I've got 6 numbers, and they're separated by commas. But if I don't declare this to be a matrix, or even if I declare it to be a matrix, but don't add this part to it, then it'll just give you a column vector. A column vector, much like that assignment down here below C1, 2, it just gives me a 1 and a 2. So here what I've done is I've entered 9 numbers, and now I want to create a square matrix. Why square? Well, if I have a non-square matrix, it's really hard to take the inverse of it. You need to take an inverse of a square matrix. Now, there are some ways that you can take a matrix that isn't square and find some kind of an inverse, but we're not going to get into that in this course. Now, notice here that I've got number of rows is 3, number of columns is 3, and this is important too, by row. If you don't put by row equals true, then it'll construct the matrix as 43, 12, and 35 as a column vector. So your first column will be 43, 12, 35, as opposed to being your first row, 43, 12, 35. Okay, so when I run this, I get no error down here. So this is where you expect the error, down here at the bottom on your console. And now I want to show you what the A is. Now notice that the A has already showed up here. All right, so I can double click it here and you'll see that it's 43, 12, 35, 16, 3, 2, 8, 11, 5. Okay, so that's one way to recover it. The other way is I just simply go Control Enter and it gives it down here 43, 12, 35, and so on. All right, now if I want to identify any element in A, suppose I want to find this element 3. 3 is in what spot? It would be down here. It would be the second row, second column. So if I want that, I go A, square bracket, second row, second column, and it automatically put the ending square bracket in that. So now what I want to do is I got to hit return, and you'll see that down here, element 2, is this 3, which is the one I asked here. So the thing to note is that these square brackets are used to identify a particular point within a matrix or a vector or wherever else. Okay, so now I want to find the inverse. So to find the inverse, I was trying to use INV, and INV is the command one uses in MATLAB for anyone who's ever worked with MATLAB and some other ones as well. But here we're using solve because the way we write it often is x equals, or pardon me, y equals ax, where a is a matrix and x is a vector of x's. And we want to solve that equation for y, and we just go solve a. So we hit return and we get the inverse, and you'll see the inverse down here is quite complicated. All right, it's something that you couldn't do by hand for sure. Well, you can, but it would be a little tricky to do. So this is one thing to remember. This is your inverse. Now I can put in here, I can put a comment, inverse A. All right, and the comment is denoted with or set off with this pound sign. And so you can put the pound sign anywhere, and anything that follows the pound sign on a particular row will be a comment, will be treated as a comment, and will never be used to solve or do something. All right, so for example, you might use it to set off certain text. All right, so when you're writing programs, sometimes it helps to set off a certain amount of text to separate one set of code from another set of code. Now, the other thing is, if I multiply A by itself, so if I go A star A, then I get Control Enter. What happens is it multiplies 43 times 43, 12 times 12, 35 times 35. So 12 times 12 we all know is 144. So you see that down here. And this 3 should then be a 9. So you have to be careful because A star A is element by element matrix operation and not matrix multiplication. Matrix multiplication is where, if you'll recall from Math 208, and as you will find in the matrix review, that you multiply a row by the column. So you take the first row of A and you multiply element 1, 1 times the element in equal element in A. So you basically take a column, a row, and multiply by the column of the second matrix. So this was a B, let's say, if matrix A was a B, the second one rather, then one thing we would have to know is that B is 3 by 3, and then you can multiply them together to get a 3 by 3 matrix. But that we discuss in the videos for matrix review. Now, the way I need to multiply two matrices is to use this function here, percent star percent. That means I'm multiplying matrices. So if I multiply this one, solve A. All right, remember that's the inverse. So if I multiply A times solve A, if I do matrix algebra, I should get an identity matrix. But I'm not doing matrix algebra. You see down here, minus 0.0708. That's because I'm multiplying this number here by 43, okay, by A. So to get the inverse, or to multiply the inverse times A, or I can multiply A times the inverse. Both ways I'm going to get the identity matrix. So if I run this one, you'll see here that I get the identity matrix. Now be careful here, because this demonstrates the problems of matrix or any multiplication on a computer. This number here, 2.77555, e to the minus 17, that's very close to 0, but it's not exactly 0. So if you want to, you have to notice that these numbers are all effectively 0, but in terms of precision, all right, sometimes you need precision, particularly if you're dealing with precision instruments, or you're dealing with measuring, for example, an atom. You might want to go lower than that. So this is not precise, and you can increase the precision of this, but we as economists don't really need to do that. But it does come up in one spot, and that is, suppose you have a matrix that's all the elements are less than 1. If you do matrix multiplication on matrix, and you multiply the matrix over and over again, matrix multiply it, then what happens is it deteriorates to 0. And that's a problem when you look at stochastic dynamic programming, for example, or Markov chain programming. And that's something beyond what you're going to do in this course, but you will do it in 351. So, be warned about that. So that's your matrix multiplication and element by element matrix, or element by element multiplication. Okay, there's another thing that we're going to look at, and that is one of the important things that you have in matrix algebra is what are called eigenvalues and eigenvectors. And that's going to come up again in your review of matrix algebra, but in particular, it's going to come up again in 351 when we're dealing with difference equations and differential equations of higher orders. Okay, and you'll see at that time how important that is. But here, I'm just going to run this piece of code by going Control Enter, and you'll notice down here that I get eigenvalues. I should have 3 of them. All right, so here are my 3 eigenvalues. Yeah, these are my eigenvalues here. And down here are the eigenvectors. They're vertical columns. So I have 3 columns of eigenvectors here. And we have some problems with this because these are imaginary numbers. Okay, so these turn out to be imaginary numbers. And that's okay because we deal with those in differential equations as well. Okay, imaginary numbers, but we're not going to really deal with that in this particular course. Okay, now I'm going to define another variable, or another vector, if you like, VV I've called it, and it's a vector of, it's a string vector. All right, here are my strings. I'm calling that a cat, dog, horse. And what distinguishes a string from a regular number is the fact that I've surrounded it with, in this case, single quotations, but you could have used double quotations as well. And then I'm going to create a matrix B, which is going to take matrix A, and it's going to put VV above it. So this is called row binding, and it's concatenating is the term we use for concatenating vectors and matrices. So that's you're putting one row above. So you have a matrix down here and you're putting a row above it. So it has to be that this has 3 elements in it because we have a 3 by 3 matrix. So when I do that, all right, I've run these 2 pieces of code. So the first one gives me that cat dog. And then I hit this one here, the R bind, and that one is looks like that. Now I'm going to just go down here and I'm just going to type B and run it. Now you'll notice that it's got these quotation marks around the numbers as well, which it shouldn't, but maybe we could solve that by looking at a data frame. And a data frame is something that you can look up. You just go data dot or data frame without the dot in R, just Google that and you'll come across this thing here. And what I've got here is a data frame where I'm taking this B matrix that I've taken, and I'm going to go row names equals null, but I should really put row names is true because the top row is true. So let me see if that works. It worked when I had null in there, and that's true. I can hit this one, which doesn't help me much. And I'm going to just hit CC and let you see what it looks like. Okay, so here now I've got cat, dog, horse, and the numbers underneath it. So this is a data frame. So this is what I would use if I were doing econometrics. Okay. So this gives you an idea of how you might start and how you might work in R using matrices and a few other things here. Now, I can look at CC and find out, what did I got to get up here. Sorry. I'm just going to put it up here. I'm going to take out and I'm going to look at dollar. So I want one little part of this, and I want to look at dog. Okay, the variable dog. And I'm not sure if this will work. No, it won't work. You'll have to figure that out because you can use this $sign to indicate a particular column or row in, I don't know if it'll work like that. No, that doesn't work either. So I'm going to have to think about, or you're going to have to think about how you do that. Okay, the other thing I want to do is I want you to know 2 things. One is you should really build a new project. And a new project you then put into a file folder. And then anything you do in that new project, let's say you have an Excel file and you want to read it, put that Excel file in that same folder, and it will automatically read it without having to put C, colon, and all that stuff behind it, and then to direct you to the proper folder. In this case, by having a project, when you open the project, all the files are in that folder to begin with. All right. So it's useful to create a folder, then create a new project in that folder, and then create new files. So in this case, I created a file by going to new file R script. All right. But what I want to do now is I want to just show you how we can create a new file, Markdown. All right. Now I'm going to just put test here, and you'll notice here that I have default output formats, HTML, PDF, or Word, and I'm just going to leave it as HTML. I'm going to go OK. Now look how this document has changed. So I'm still in this editorial mode or this edit mode here, but now I've got, I can write things. All right. So for example, I can write this. I'll put a pound sign. Now the pound sign is totally different because I'm writing code. I'm writing text for LaTeX kind of text. This is a test of the Econ 350 class. All right. Now, there's some other stuff in here. And if I run this, I can run chunks of code. The chunks of code are in these gray bars. And those chunks of code here, you'll see that I've got an R, but I can put Python in there as well, or C. Any one of those would work. So I could have a piece of code that is in C. I can have a piece of code that's in R, and I can have a piece of code in Python, and we'll run all three of those. The thing here is that I want to declare, say, pressure being my key to what that particular chunk of code is about. And then I can say echo false to prevent any of this code from being written into the document that I create. Furthermore, I can, within the written components, all right, within these written components, I can put links to R as well by writing something like this. Notice these three little dots here, or where they found they're on, I believe they're on the keyboard under the escape tab, where you get the little squiggly line. Down below that is this thing here. Let me just see if that's true. Yeah, that's the, does that look the same? Yeah, it looks about the same. So now, once I've done that and I've done all my code and everything else, I can publish this by going to something called knit up here. And I have to point out that you have to download the package called Markdown. So I think I've got Markdown in here somewhere, HIJKL. This solve here, LP solve, we will be using. And here's my Markdown. All right. So here I've got the package Markdown in place. I could put LP solve in there as well, and you'll see that it runs. Or I can put library and then in brackets put LP solve. All right, so now I'm going to knit this file, and I'm going to knit it to HTML, and it'll need a, I don't want to, yeah, okay, this is just a test, HTML, and I'm going to just save it there, and it'll pop up in a minute, and it'll show you how that, notice here, introduction and Markdown. Introduction, I used $1 sign. Markdown, there were 2 for our Markdown, including plots. Where did that one disappear to now? There we go. So you'll see that here's my written text, and here are the results from one of the code chunks, and then including plots. You'll see including plots, and down here I've got echo false. So all it does is provide you the output of the plot, and it doesn't provide you the raw code that is making the plot. So as you can see, you can also embed plots, for example, and they're embedded right in there. So Markdown is something that some students like to use who are a little bit familiar with LaTeX, and even if they're not, they like to use it and thereby use it to produce documents that they can hand in for classwork or create an HTML or something along those lines. All right, the last thing that I should point out is that once you've determined where your folder is and you've created a project file, then you can see everything that's in that folder here under files. Under packages, you may find that in order to run a particular program, you need a package. So you can install the package by clicking here, and you get the name of the package, and it's usually in this repository CRAN. Now you can also do it if you click here, that you can take a file, for example, a zip file or a tar.gz file that you get off of a website or something like that, and then you could, it'll unzip it and do all that's required to make sure that you install the particular package. most packages, you just have to hit the install button, put the name in, and it'll come up and you click on it and it'll install it. All right, and you'll have to figure out sometimes when it doesn't quite work the way you want, you may have to Google it and find out some more details. Okay, that's all I wanted to do on that, and I think I will now stop recording. Thank you for watching this video. There are many more videos in this 2 to 3 course series. A list of videos, the order in which they should be taken, and links to them are found under Mathematical Economics at the website indicated below.